All right, question number 4. Again, what type of question is question number 4? Before is a diffie-q, right? Number 4 is a graph question, that you're given a graph and you have to be able to answer these questions off the graph. So you're given the graph, you're told that there is a turning point at -2, a maximum. From 0 to 7 is a linear, that's a line, so that's a triangle, and that's a triangle. This is just an area. That region R that's shaded that's given already. It's 12. I don't need to find it. And it says the vertical line x equals -6, x and y axes. All right, it's bounded by that. So you can see where we're going from here. All right, so let's go for part A and write down what it tells us to write down. So we're on question number 4. This is A. And it says g at x is equal to the integration from 0 to x f at t dt. And then it gives me questions. Can you find g at -6? So I'm going to plug in -6 for x and then answer it. So how do I integrate off a graph? Well, that means that you find the area. So one thing I notice is that 0 is a larger number than -6. This is improper. So we're going to start with the negative in parentheses and then put the answer inside the parentheses. So from 0 to -6 is just a shaded area, and we're told that area is 12. And because it's improper, that's why there's a negative in front. Done. Next, can you find the value of g at 4? So we're going to integrate from 0 to 4. Oh, should be a t. Now notice the bottom number is smaller. It's proper, so I don't need a negative in parentheses. So from 0 to 4 is just this triangle. It's above the axis, so it's positive. That triangle is half the base times the height, and you don't need to simplify it. The next number is at 6. So we're going to integrate from 0 to 6. So when I integrate from 0 to 6, again, the bottom number is smaller, so it's a proper integral. So when I go from 0 to 6, I have the triangle I found already, and then the second triangle is here, and that is below the axis, so it's going to be a negative value. So we did the first triangle, which is 1/2 the base times the height. Then the second one's going to be negative when you do half the base times the height. And you don't need to simplify it. All right, part B. For the function g defined in part A, find all values of x in that interval which the graph of g has a critical point, and give a reason for your answer. So g has a critical point when the derivative is equal to 0. So the derivative of g, the derivative of this equation, is the fundamental theorem of calculus, the second part. The derivative and integration undo each other. And so x just gets plugged in. So the derivative of g is just f at x. And so off the graph, what we're looking for are the x-intercepts. And so when I look off the graph of f, the x-intercept is at 4. And so when x equals 4 is a critical value, or a critical point. And this is explaining how you got your answer. Part C. You're given another function, h at x. We're going to write it down. From -6 to x, of the derivative of that. And again, we're going to find values. So if I ask for h at 6, I'm going to plug in 6. Now, the graph is not the derivative, so we don't do it with finding the area for this one. Instead, when we integrate a derivative, all we have to do is work backwards, and it's just f at, so what's the antiderivative of f prime at t? It's f at t. And here, I can even write down. It's just f at t from -6 to 6. So the antiderivative of this is just f at t from -6 to 6, and then you plug in 6, and you subtract, and you plug in -6. So off the graph, what's the value at 6? That's -1. Off the graph, what's the value at -6? It's 0.5. And you have your answer. The next one is h, the derivative at 6. So if I take the derivative here, I'm going to write that down here. The derivative of h, again, if you take the derivative here, x gets plugged in, and it's simply the derivative of f at x. So it crosses out with the integration. And then we can plug that in. And it says, what is the derivative at 6? So derivative off a graph means slope. So at 6, what's the slope of this line? And if you count, you can count down 2 over 4 or down 1 and over 2. It doesn't have to be simplified, but it's negative a half or negative 2 over 4. The last one is asking for the second derivative at 6. So to understand the second derivative at 6, it's going to match the second derivative of f at 6. This one's a little trickier. So the second derivative has to do with concavity. So at 6, is it concave up or concave down? The trick, the hook is it's a line. A line has no concavity. So it's not undefined, it has no concavity. So we would say the answer would be 0 because there is no concavity for a line. And that's it. All right, Mr. G Math over and out. There was question number 4.